So looking at the first problem, it says which one of these salts is least soluble at 10 degrees. So I go, here I am 10 degrees, or up until I hit the lowest line. In this case, it's potassium chlorate. Had they wanted to know which one was the most, I'd just go up there and it'd be Ki. Which of these salts has the greatest increase in solubility between 30 and 60 degrees Celsius? So I'm looking at which one has the greatest slope. So from 30 to 60, it looks like potassium nitrate has the greatest increase in solubility. Which one of these salts is least affected by a change in temperature? So I'm looking for the one with the least slope, and it's clearly NaCl. All the other ones show a much greater degree, either an increase or decrease in temperature. So at 20 degrees, a saturated solution holds 100 grams. How many grams must be added to make it saturated at 50? So 50 degrees and sodium nitrate looks to be about here. So I added 100. How much more could I put in there? Looks to be about 15 more grams. So for this one, we're looking for where they have the same solubility, or I mean at which temperature they have the same solubility. We're looking for the temperature at which they cross. So we've got potassium nitrate and sodium nitrate, and it looks like they cross right around here, about 71 degrees Celsius. Which two salts have the same solubility at 18 degrees Celsius? So I'm going to go up at 18 until I find two lines that cross. And it appears to be these two, potassium nitrate and potassium chloride. How many grams of potassium chloride must be added to 1 liter to produce a saturated solution at 50 degrees? So this one is involving a different amount of solvent, not the 100 grams that our graph can read. So we'll have to solve it for the 100 grams of water and then alter it for the fact that we have 1 liter. So they want to know a saturated solution of potassium chloride at 50 degrees. So I take 50 degrees, go up until I hit potassium chlorate, and it looks to be about here. So this is for 100 grams of water. So 21 grams per 100 grams of water equals X per 1,000, or 1 liter of solution. And when I cross multiply, I find that I could fit 210 grams. So you solve it for 100 grams of water and then just alter it with a ratio to figure out how much for a liter. So I've got a saturated solution of potassium nitrate at 60 degrees. So potassium nitrate, 60 degrees here. And then they say I'm going to cool it down to 30. Looking to be about here. The difference between these two is going to be the amount that will precipitate out, leaving with a saturated solution at 30. So I subtract out and I get about 58 grams, depending on how you interpret the curve. So this one's looking at the rate, or really the slope of the graph. They want to know the grams of solute per the temperature. So I'm going for 60 to 70, and it's for potassium nitrate. So I got potassium nitrate here at 60 degrees, and I got potassium nitrate here at 70 degrees. So it looks like I'm going from about 107 grams to about 133 grams over a 10 degree temperature change. So I'm going 26 grams per that 10 degrees Celsius. So if I subtract those out, divide those out, I find that I'm going to have a slope of about 2.6 grams per degree Celsius. So this one too, you can see we're looking at a different solvent amount of 50, so we'll solve it for 100 and then set up a ratio to solve for 50. So we've got a saturated solution of potassium chlorate at 20 degrees, so 20 degrees potassium chlorate. Go up until I hit the line. So I can fit about, let's call it 9. So 9 grams and 100 grams of water How much could I fit in 50? I cross multiply and I can fit half as much, about 4.5 grams of potassium chlorate. So we've got 30 grams of potassium chloride, at 45 degrees Celsius. And I want to saturate it at 80 degrees. So 80 degrees potassium chloride. Looking at there, so how many more would I have to get? We just subtract the two amounts. It looks to be a little over 20, we'll call it 21 grams. What is the smallest amount of water required to completely dissolve 39 grams of potassium nitrate at 10 degrees? So at 10 degrees for potassium nitrate, I'm looking at here, and it looks like I'm going to have to set up another ratio. So I'm going to put the 23 over the 100 grams of water, and then we put the new temperature over the new amount of water. So kind of a different play on changing the amounts around. We're still staying So what is the lowest temperature at which I can dissolve 30 grams of potassium chloride in 100 milliliters of water? So we got 30 grams potassium chloride. Looks to be about 10 degrees Celsius. So for these, we're figuring out if they're on the line, they're saturated. If it's below the line, it's unsaturated. And if it's above the line, it's supersaturated. So 40 grams at 80 degrees is going to put me here. And because we're looking at potassium chloride, which is this line here, we appear to be below it. This must be an unsaturated solution. Next one's 120 grams at 60 degrees, so 120/60 looks to put me here. They're asking about potassium nitrate, which is this line here. It appears to be above the line, so this must be a supersaturated solution. 80 grams at 10 degrees appears to be right on the line for sodium nitrate. That makes this a saturated solution. So carbon dioxide at room temperature, you guys know, is a gas. And we know that gases show a decrease in solubility with an increase in temperature. So this would slope downward, much like the ammonia and sulfur dioxide do on this graph. So hopefully you're getting a better hang for how to do these. It's really all about practice. The more problems you do, and the more you watch them getting solved, the better off you'll be. So don't be afraid to go back and watch the other video, watch this video again. But there are more problems that we'd like you to try before considering yourself mastering the material.